Now, in this section of our study of the laws of science, we're looking at physics, and we're looking at the mechanical things that exist in physics. You know, God has created the creation with certain rules, certain laws that make things work. And the guy that first discovered how these things work together was a man by the name of Isaac Newton, who did some really simple stuff and came to understand that there are three things that are involved in all the mechanical motions that happen on the earth. One of those is force. Force is a push or a pull. When you push something, you use force on it. And we measure force in the English system in pounds. In the metric system, we use newtons and dynes. These are just different ways of measuring a push or a pull. One of the forces that you're most familiar with is gravity. Gravity is a force. It is the pull of the earth on an object. But there's another quantity, and that's called mass. Mass is how much stuff there really is, how many atoms there are in something. So you are made of atoms and you have a mass. But that mass is pulled upon by gravity. And we measure mass in different units. In the English system, we use slugs, and you probably never heard of that one. In the metric system, we use grams or kilograms. Let me show you how different these two units are. When you go into orbit around the Earth, will you become weightless or massless? Now, I hope that you said weightless, because weightless is when the pull of gravity is counterbalanced, is canceled out by something. And we'll talk about what that something is later, but when you go around and around the earth, there is a force that cancels out gravity, and you just don't feel any pull upon you. You become weightless. What would happen if you became massless? Hey, you wouldn't have any substance. You'd cease to exist. There wouldn't be any you. So mass is how much stuff there is. And you can have something that has a huge volume, like a balloon full of hydrogen, but it has very little weight. It has very little pulling on it. Now, when you have weight and when you have mass, when you have force and when you have mass, there's a third thing that happens, and that's called motion. So what Newton did was he talked about force and mass and motion. So let's look at what I have on the table here. I have a cart. That cart has a certain mass. It's made up of certain molecules. It also has a way of pushing the cart. So to make sure we get the same amount of force each time, the cart has a little plunger, which you can see here. And so I can take that and push it in here, and it will work on the notch. And then I can take a hammer, and when I hit this nail, it will push that thing down and make the plunger go. Let's watch that. So that'll push the plunger. That's the force. How much stuff there is in this cart is the mass. So let's put it down here and let's see what happens. I'll set the force here like that. We'll put it up against this little box to hold it at the end. And then I'll tap on that nail so that plunger shoots. And watch what happens. Motion. The cart took off, didn't it? The cart took off. So there's a relationship between the force that pushes the cart, how much stuff there is on the cart, and how fast it goes. Now, how fast it goes, the speed at which it moves, is controlled by something called acceleration. You know, there's a thing on your car called the accelerator, and when you push down on it, the car speeds up. It changes its velocity. So when I push on that plunger, the car accelerates. It moves really, really quickly. So the laws of motion, the mechanical laws of motion that Isaac Newton discovered and that God put in place to make things work on the earth, describe that motion. The first law says that things will stay the way they are unless something acts on them to make them change. Now that may sound kind of silly, but it's pretty important. You know, when you push the cart moves, and it will keep moving until something stops it, until it runs into the pillow. Or in this case, another thing that will stop it, like that, is friction. So the first law says things stay in motion until some outside force acts on it, or they stay put until some outside force acts on it. So if nothing pushes on that cart, it'll just stay there. Now you say, well, I knew that. Well, of course you did, because you live on the earth and you live according to the laws that God has given us. Think about it when you're orbiting the earth in a spaceship. You can go around and around and around the earth for a long, long, long time. When the shuttle gets up there, when the space station's working up there, it stays there because of the first law. Things stay in motion until acted upon by an outside force. And up in space, there's not much to slow it down. It doesn't have wheels, so there's no friction. It doesn't run into other things very much. So it takes a long, long time to slow things down. Boy, is that important to space travel. So the first law says things stay the way they are until acted upon by an outside force. The second law that Newton discovered has to do with the way in which things move compared to their size, compared to how much mass they have. Not the volume, but how much mass they have. Now you remember how fast this thing moved. Let's do it again. We'll set the trigger, we'll put it here, and you watch how fast it goes across the table. All right, now we're going to reset this and we're going to change the mass. And we'll do that by putting some weights on the cart. Now what I'm doing here is that I am increasing the mass of the cart. There's more stuff there than there was before. And watch what happens now with the same force, because I'm not changing the force. I'm using the same plunger in the same setting that I had it before. Watch what happens. Doesn't go as fast, does it? And that's a pretty common sense thing. The force that you exert is equal to how much mass you have multiplied by the acceleration, how fast the thing takes off. Now, if I were to change the force, suppose that instead of putting it in that first notch, suppose I put it in the second notch. All right, now what's going to happen now is that I got a lot more force on there. What's going to happen? Right, you know what's going to happen. It's going to go faster. Let's try it. Oh, it went so fast it shook some of the mass off. So you have to realize that that's a law that God has put in motion to help the way things move. Now there's a third law that we can show here, Newton's third law. The first law says things stay in motion, stay put until acted upon by an outside force. The second law says that force is equal to the mass times the acceleration, that how hard you push it, how much stuff there is on it, controls how much it moves. And the third law says for every action there's an equal and opposite reaction. And you saw that. When I pushed this thing in, what did the plunger do? It went that way, didn't it? So what does a cart have to do? Yeah, it has to go the other way. And that's called Newton's third law. For every action, there's an equal and opposite reaction. So when the plunger goes that way, the cart goes that way. And when the cart hits here, it bounced back. Because there again, there was an action. There needed to be a reaction. One last thing I want to tell you about this, and I'll show you something really weird. There's also a thing called momentum. Momentum is what allows the cart to keep moving, even when it hits something on the outside. So for instance, if I were to put an obstacle in the way of this cart, just a little tiny obstacle, not a great big obstacle, but a little tiny obstacle, like for instance this cough drop, and if I set my plunger and the cough drop is there in the way, what's going to happen? Is this going to hit the cough drop and bounce back that way? Let's try it. See what happens. Well, it sort of ran all over it, didn't it? Well, why'd that happen? Because this has a lot of momentum. Momentum is the mass times the velocity. It's how much stuff there is there and how fast it moves. This thing didn't have much momentum. First of all, it doesn't have much mass. There's not a whole lot of molecules there. And secondly, it wasn't moving. So you're watching a football game. And there's a great big huge fullback running towards the line. And he's running really, really fast. And he hits the line and he goes into the end zone. Why? Because he has a lot of momentum. His momentum carried him into the end zone. That's a product of how big he is and how fast he goes. So does a bullet, when it's fired out of a gun, have a little momentum or a lot of momentum? Yeah, it has a lot of momentum. It doesn't have much mass, but it has a huge velocity. So there are two things that you need to have momentum. You need to have mass, and you need to have velocity. So we've talked about the laws of motion as they are designed for the earth to allow us to be able to live on the earth and throughout the solar system. God made his laws of motion just like his other laws so that we could live and enjoy life.